This is 12-2, arcs and chords. Take a minute to try the warm-up and hit play when you're ready to see the answer. Notice in the first two of the warm-up, I actually did this in two different ways. A lot of you probably know the blue, the is over of equals percent over 100, also known as percent proportion. Now, the big one that we're going to use in this chapter, I would say, is the third one. If something's 29% of this pie chart, well, 29% means 29 over 100. It's the same thing. Percent's always out of 100. Times 360, because it's 360 degrees. So it's the percent of the circle, which is 360 degrees. And of means to multiply. So you take the percent and you multiply it by 360. That's how I got 104.4 degrees. Here's some vocabulary words for you. So first we have essential angle. Essential angle we already saw was 360 divided by n, but it's an angle whose vertex is the center of a circle. So for instance, here we have essential angle that I marked in green because the vertex is the center of the circle. Okay, a minor arc. Just think of that as like a small arc. A minor arc is an arc whose points are on or in the interior of a central angle. The measure of the minor arc is equal to the measure of its central angle. So if the central angle is 29 degrees, the minor arc is 29 degrees. A major arc is an arc whose points are on or in the exterior of the central angle. It's like a larger arc. The measure of a major arc is equal to 360 minus the measure of its central angle. So if the central angle was, for instance, again, we'll just call it 30 degrees this time. If the central angle is 30, then the minor arc is also 30, but the major arc would be 360 minus 30, which makes sense since the full circle is 360 degrees. If the endpoints of an arc lie on a diameter, then the arc is a semicircle. The measure of the semicircle is equal to 180 degrees. Now this one is actually really important for the work that we're going to do. So anytime that you have a diameter involved, then that arc's measure is going to be 180 degrees since it's half the circle. So keep that in mind. Okay, here we have a circle graph. It's asking us to find the measure of arc. Notice how the arc is displayed with that curved line above the letters KLF. So arc KLF. Okay, so since this is 65%, remember percent is out of 100. So it's going to be 65 out of 100 since it was 65% times 360 degrees so that we can see how many degrees just the arc is. When we calculate this, we get 234 degrees. So we would write the measure of arc KLF, see the arc symbol, is equal to 234 degrees. Okay, now you try and hit play when you're ready to see the answers. Okay, in the first one we had to add together 9, 10, and 11%. So we got 30%, which means that's 30 over 100 times 360, which is 108 degrees. And the next one I took 100% minus 25%, which is 75%. So I used 75%, which was 75 out of 100, times 360 degrees, 270 degrees. And find the measure of angle EMD. So EMD. Okay, since that's 10%, 10% is going to be 10 over 100 times 360, which is equal to 36 degrees. Adjacent arcs. Remember we had adjacent, I think we had adjacent angles at one point. Adjacent means right next to. So if we have adjacent arcs, they're right next to each other. And just like we had a segment addition postulate or an angle addition postulate, if you have two arcs added together, then it equals the measure of the full arc. So the full arc measure of arc ABC is equal to the measure of angle arc AB, plus the measure of arc BC, which makes sense. Okay, I've highlighted arc BCD. There's actually a couple of different ways to do this. The first thing that I noticed is that I have some vertical angles right here. If you notice, these two, I don't want to use the blue. Let's see, so we've got these arcs right here form vertical angles, angles right across from each other. So therefore this is 97.4 degrees as well. And I just need that missing piece, I don't know this angle measure, so that I can have all that's marked in blue. But what I can do is this total, let me highlight in a different color here, I'll use yellow. We've got this line segment BE, that is a diameter. So I know that the measure of arc BCD plus the measure of arc ED is going to equal 180 degrees. So I have my 97.4, and I could subtract that from 180. Oops. 180 from the diameter, since that's what the diameter equals, minus the 97.4 minus the 52 that we know will give me that question mark that I've placed there. So let's see, that little arc CD is what I'm looking for. That's 30.6 degrees. And now that we know that, we can add together the 97.4 plus the 30.6 so that we can figure out just the arc BCD only. So 128 degrees. So the measure of arc BCD is equal to 128 degrees. Try the now you try and hit play when you're ready to see the answer. Here are the answers to the now you try. So in the first one I had to use the diameter again, and I had to subtract out the 140 that we knew so far. So that left me with 140 degrees for my arc. In example B, I used the whole circle, 360 degrees, and I need to subtract out the 40 and the 25 angle or arc measurements. So my answer is 295 for that one. Okay, within a circle, congruent arcs are two arcs that have the same measure in the figure. So for instance, arc ST and arc UV are congruent. Here's some theorems for you. So first we have congruent, central angles have congruent chords. So for instance, if the central angles are congruent, then the chords formed between those angles are congruent. Congruent chords have congruent arcs. So if you have congruent chords, then those arcs are congruent. And congruent arcs have congruent central angles. So the congruent arcs would mean that the congruent angles are congruent. Okay, in the first example, since we know that the chords are congruent, then we know that the arcs are also congruent. So we're going to do 9n minus 11 equals 7n plus 11. We're going to solve that. We end up with n equals 11. And so in order to find the measure of arc WS, we would have to plug that back in to 7n plus 11. So 7 times 11 plus 11, which is 88 degrees. In this next one, since we have congruent central angles, then we have congruent chords. So we can set these equal to each other. Solve that, we should get t equals 3. And then we plug that back in because they want nm. So since nm equals 5t plus 1, we just plug in the t is 3. And we get the nm equals 16. Try the now you try and hit play when you're ready to see the answers. So for the now you try example A, we end up with RT equals 12. Here we have congruent chords, so therefore the arcs are also congruent. So I set these equal to each other. And subtract 30y, I get negative 5y equals negative 20. So y equals 4, but they want the measure of arc CD, so I plug the 4 in. So the measure of arc CD is equal to 25 times 4, which is 100 degrees. Okay, a couple more theorems. In a circle, if a radius or diameter is perpendicular to a chord, then it bisects the chord and its arc. So here, if I'm saying that CD is perpendicular to EF, I need you to know that CD bisects EF and arc EF, meaning that these pieces are congruent and so are the arcs. Okay, in a circle, the perpendicular bisector of a chord is a radius or a diameter. So if JK is the perpendicular bisector of GH, then we know that JK is the diameter of the circle. For problems that look like this, where we have the radius perpendicular to the chord, bisecting the chord, what we actually need to do is draw a right triangle in here. So if I draw that right triangle in there, then I can find the length of SP, because I already know that the radius is 17, 8 plus 9, right? So this RP is 17. So if I just redraw that right triangle for you, oh, that's bad. We know this is RSP. This little piece is 8, and the radius had to be 17, just like the original radius RM was 17. And so then I'm just using Pythagorean theorem. So a squared plus b squared equals c squared. So 8 squared plus b squared equals 17 squared. 64 plus b squared equals 289. Subtract 64. 225. B squared is 225. So that means that b is 15. So that means that SP is 15. And then what I do with that, if we're looking for the whole length of the chord NP, I know that it was a bisector, so this would be doubled. So NP is 2 times 15, which is 30. Now I've answered the question. Okay, so in the next one, what you need to ask first is what is the length of the radius? Well, the radius is 20. So if I just add in my radius from P to R, I can then draw my right triangle. The hypotenuse is 20, since the radius is PR, would be 20. And that's 10, and so I go through the same process. A squared plus b squared equals c squared. 10 squared plus b squared equals 20 squared. 100 plus b squared equals 400. B squared equals 300, square root both sides. And b is equal to 10 radical 3. You could also get a decimal for that, but 10 radical 3 would be the most accurate. So if you want to, you could calculate a decimal. And so what that meant was I was finding out TR was 10 radical 3. But what I really want is QR, which is going to be 2 of those. So 2 times 10 radical 3, which is 20 radical 3.